Rost and I teach at Baker High School. I teach 10 through 12, and I have 3 sections of biology. And so this year what I focused on, my number one focus was integrating engineering into biology, which is a huge challenge for me. And this year I was like, I'm going to do it, and I'm going to go all in. And then the other task that we had this year as part of our group was to integrate cross-cutting concepts. So that's the focus of my conceptual change this year. This is a graphic that I kind of put together. This is how I think of 3D teaching. And disciplinary core ideas is big, but it's not supposed to be. I just couldn't get it to, it didn't look right when it was small. So they are all equal, and they all work together, and they all roll together, and that's how our lessons should be intentionally built. This is also a really good graphic from Concord.org that we've all seen, and so this is kind of how I conceptualize 3D teaching. One piece in biology that I really struggled with teaching, period, was photosynthesis. And I had trouble with my students leaving my class knowing anything more than they did coming in. They all pretty much knew chloroplasts photosynthesize and plants are green because they photosynthesize and they make sugar from CO2. They all knew that, and when they left, I don't think they knew anymore. So that was a really big struggle for me. The way that I used to teach it one-dimensionally was just focusing on content. We would do worksheets. We would draw chloroplasts and label them, and a little bit of focus on structure and function. I actually, in my cell organelle unit, I did do a piece where I focused on structure and function for that cross-cutting concept. And then I did the second piece where I focused on energy and flow, energy and matter, which was another cross-cutting concept. And I was really intentional about separating those and making it really obvious, like Stacy said, really obvious what I wanted them to focus on. So this is the stuff we did. And I want to make a note that we still did this year. We still had this background knowledge. I still do worksheets, and I'm kind of struggling with that, and it's probably because I'm really tired and I'm really slammed and I've got a lot of stuff to do, and it's really hard to develop a lot of these really great lessons and not fall back on some of those things. So I think I'm kind of in the middle of that, and I don't know what to do with that. Here's a graphic I used, and we pieced it out, and they know light and dark, and they know the formula, and then in previous years I've added the practices. They would construct explanations. We added that practice. They would also design experiments. They were kind of cheesy. They were canned. They were cookie cutter. We would do modeling. We would act it out. We'd rip water and all of those things too. But this year I really wanted to focus on the third dimension of energy and matter. And so I made that my focus, and that was my lens, as Chris calls it. That was what I was focusing all my energies on. So what I had them do was we actually made a working model of a chloroplast. And so I found this, it's pretty new. Arbor Science sells it. It's a kit where they make a solar cell, but it's out of photosynthetic pigments. And I wanted them to understand that solar cells work the same, and that we should model a lot of things in engineering on biology, and that's done a lot. So I wanted them to see that and to do it. And so, and they had, I also added in chemical engineering. I wanted them to see that all the sciences are together, they're all one. So we had a lot of physical science in this, which I'll show you in their background knowledge. And their task was to engineer the perfect solution of plant pigments to collect the most light. So another really big practice that I focused on, like I said, this year was engineering, and this was how I fit this in, and I tried to do it in every unit. I also try to make my units focus on the project that they're going to do at the end, so they need to know all this background knowledge in order to be successful in the project, and I've really tried to be intentional about that and talk about it every day. You need to know this because you're going to be successful in this project if you know this. So this is what the solar cells look like. The kit is from Arbor Sci. I think I have that. And they're about $110 for a kit, and that served about 45 students. And then they have refill kits, and so they're just, and I'm not, the point of this isn't go buy the kit. The point of this is how I transform my photosynthesis unit to be a lot more meaningful. So it's just 2 pieces of glass, and then the dye is soaked, the pigments are soaked in that, and then they put them together, and you run light through it, and you hook it up to a multimeter, and it collects energy. So first they prepared the glass slides, and then the big part was designing the plant pigments to capture the full spectrum of light. And I'll show you what that looked like. And this is just a graphic of what the 2 electrodes looked, what the solar cell looked like. So then they slammed them together, they put some iodine, and then they tested them. But that wasn't the focus. So some of the prior knowledge they needed to know that we did in probably 1 and 2 dimensional methods. They needed to know basic photosynthesis knowledge. Plants take in light energy and they convert it, and it's a 2-step process. And they also needed to know about the visible light spectrum, and that white light is all the colors of light. And we pulled that from physical science. And then this is kind of their catchphrase now: plants are green because they aren't. And they said, my shirt's blue because it's not. So that's kind of their funny thing now. So plants absorb red and blue and they reflect green. And that was a big piece of this. So another piece of equipment that we have is the Spectrovis Plus from Vernier. And it measures, it's just a spectrophotometer, and it measures color of a solution. So I showed them a picture of chlorophyll and the colors that chlorophyll absorbs and what it reflects, because this is absorbance. And then this is also anthocyanin, so it's showing that it absorbs green and reflects red and blue. So if you put those two together in the same solution, is that additive? Are you going to get a straight line, or are you going to get full spectrum absorbance? That's what you want. That's more energy being absorbed. That would be ideal. So that's kind of what they focused on. And they made predictions. I made them show me what would your graph look like if this was successful, if this is the pigment that you want. And then their next step was, and I think I have time for this, their next step was making the pigment. So I just have a whole bunch of videos compiled showing their discourse and their conversations that they were having while they were making their pigments.
Oh, okay. Because these two both have more color, it's going to take away from that one.
We should put white. Guys, we should just put all the colors in there. We're going to Google what's best.
Oh, I don't know. It really hasn't been studied, honestly, if you test it.
We'll try it. This will kind of make it greener, lighter color.
How about you pour some of the liquid? No, don't pour that in there. Pour the liquid in there.
Yeah.
What do you have?
I have like, mine's also blackberries, some blueberries, and then algae.
What do you have?
Just blackberries.
And you're just doing raspberries? I forgot to mention that for the anthocyanins and the other pigments, we use berries. So, obviously, and then we're going to bring in the chlorophyll. Sorry.
Raspberries and blueberries.
And I did one of everything.
I feel like blackberries are best because they have lots of colors and they have like red, and they're like light but also dark. Are you ready?
We're trying to get as many colors in it as possible so that it turns black eventually. Or as close to black as we can.
Okay, so what are you seeing there?
It absorbs a lot of blue.
What do you want it to absorb more of?
The greens.
Yellows.
And
And red.
the red. So what are you going to add to make it absorb more red? No, they reflect.
So blackberries.
Maybe we should try.
But also if you add more green, they're going to absorb more red, because chlorophyll is green and it absorbs a lot of red.
Some more algae.
And we're going to go to the greenhouse pretty soon to get more of your green. So you want to see more in the red too.
Yeah, so.
So what could you add to get it more in the red? What color would you put in to get more red absorbed? You'd have to put the opposite of red. Yeah. Well, the blueberries and stuff, what did you put in there?
Blueberries, raspberries, and also.
Okay, if you put green, green is also going to absorb red.
Okay, so.
So that's, so that's why we're going to the greenhouse.
So that's what we were missing.
Alright, a little bit of these things. This is dark.
Take a prayer, turn this off.
So you might be Try to get more. Yeah, there's a whole bunch down in the bottom. It's all on the bottom there. The leaves down there on the ground, they have purple on the underside. Those might be kind of neat to look at. Did you guys see that plant down there? It has purple on the underside.
Oh, Lord. Start in the box.
They'll definitely. I think this one.
Do we want like a separate scratching kit for this?
You could, and you could test it separately. You could test each leaf separately to find which one has the best, you know. Okay.
All right, we ready?
So just real quick, that's what dyeing the solar cells look like. So you just put it in the stuff and then leave it in there for 5 minutes. You put them together and test them. We used an overhead projector to keep consistent light. I wanted to show you what some of the notebook samples look like. This is labeling the chloroplast. Big deal. This is just some notes. This was this year before we did this. This is just some notes that they took and some of their notebooking. Another student's notebooking. And then this was the actual solar cell challenge. So this is their write-up. They also had, I demonstrated the procedures. I don't give them pieces of paper for labs anymore at all. They don't do that. We don't do cookbooks. So I demonstrated it because there were some things that they needed to know, and they wrote it down in their own words because we work on procedural writing. And then this was their write-up, so they all had graphs printed, and then they were able to analyze it. And one thing that I kind of struggle with engineering, because I'm a lot stronger in experimental design and that part of it, and I think that engineering is a really good way to integrate experimental design and collecting data and then making revisions, and so I think it's a really good way to marry the two. And it also kind of serves as it's motivating for the students, and their engineering makes it a lot more fun. And then I just threw some other notebooking samples on here. So that's mitosis, and they had to put them in order, and then someone's did. So and that's the answer to this first. Yeah.
On the, you just mentioned about integrating some engineering. Did you give them some prompts, or how did you integrate it, or did you try to get the kids to implement some refining of that?
That was testing the solutions, because they could keep coming back as many times as they wanted. They had, I think, we basically took 2 days to do it, so 3 days with making the glass plates. We did that on part of the day. So they spent like a whole day making the solution, and they could test it as many times as they wanted. And I wanted that to be, that's why I added the spectrophotometer, because I wanted that to be iterative and where they could keep revising it. And a lot of them, the video didn't show this, but a lot of them took each sample separately and tested them and then put them together. I loved that. And they were not additive. We found some really weird things, and there's just so much exploration, and the video I didn't have all of it videotaped. I wish I had a videotape on all the time with my kids. But so I really liked that part, because it was a really cool way to add that piece of revision. And obviously the point of this isn't to go and buy all this stuff. The point of it is I would really challenge you guys to look at a part in your content that you struggle with and go all in and find a way to engage students. And I would also encourage you to add engineering to it if you can, especially in life science, because that is a really effective way to engage students, and they learn the content a lot better and they talk about it. And I can say that every single engineering piece that we've done this year in biology, that's all they talk about. And if you focus on one piece of the content or one piece of the unit as a central piece, then they'll remember that, and then everything else kind of stems from that. And then when you're adding cross-cutting concepts, pick one. Sometimes you can add practices together and do more than one, but I would encourage you to pick one cross-cutting concept and design your lessons through that lens. And it makes it a lot more intentional. So, that's it.